After a 9-year journey, NASA's New Horizons finally reached Pluto, and what it revealed shocked scientists. Instead of a lifeless dot, they found mountains, glaciers, and signs it might even hide an ocean. But Pluto has always been controversial. Once known as the 9th planet, it was reclassified in 2006 by the International Astronomical Union, leaving our solar system with 8 official planets. So the big question remains, is Pluto truly not a planet, or did we just change the definition? In 1930, a 24-year-old astronomer named Clyde Tombaugh was scanning photographic plates at Lowell Observatory in Arizona. He was searching for Planet X, a hypothetical world believed to be tugging on Neptune's orbit. And then he saw it, a tiny moving speck. That speck was Pluto. When the discovery was announced, the world celebrated. The solar system finally felt complete. 9 planets orbiting the sun. Pluto quickly became iconic. It was small, distant, mysterious, but it was part of the family. Children memorized it. Scientists studied it. Artists imagined it. However, science is not sentimental. By the early 2000s, astronomers had begun discovering other Pluto-sized objects in the outer solar system. One of them, Eris, was even slightly more massive than Pluto. If Pluto was a planet, should Eris be one too? And what about others? Suddenly, the solar system risked expanding to dozens of planets. So in August 2006, under the authority of the International Astronomical Union, astronomers voted to redefine what planet means. The new definition required 3 conditions: orbit the sun, be round due to gravity, clear its orbital neighborhood. Pluto satisfied the first 2, but not the third. It shares its orbit with many icy bodies in the Kuiper belt, and with that vote, Pluto was reclassified as a dwarf planet. Public reaction was intense. People felt like Pluto had been demoted, like something had been taken away. But while Earth argued, something extraordinary was already happening. On January 19, 2006, months before Pluto was demoted, a spacecraft blasted off from Cape Canaveral. Its name? New Horizons. Launched by NASA, its mission was simple in description, but historic in scale. Travel over 3 billion miles. Reach Pluto, reveal it. The journey would take 9 years. 9 years of silent travel through deep space. The spacecraft would move faster than any previous mission leaving Earth. It used a nuclear power source because sunlight would be far too weak for solar panels. As it traveled outward, the sun shrank. By the time it approached Pluto, sunlight was 1,600 times dimmer than on Earth. At that distance, shadows are soft. Time feels frozen. And then, on July 14, 2015, humanity saw Pluto clearly for the first time. The first close-up image stunned scientists. Pluto wasn't a gray, crater-covered fossil. It had color, reddish hues, and dominating its surface was a bright, heart-shaped region later named Tombaugh Regio. But the heart was not just beautiful, it was young. In space, surfaces accumulate craters over billions of years. The more craters, the older the terrain. However, this region had very few. That meant something shocking. It had been resurfaced recently, geologically recently, which was impossible. Small worlds cool quickly. They lose internal heat. They become inactive. Pluto was supposed to be dead, but it wasn't. New Horizons revealed mountains rising up to 11,000 feet high. But these mountains weren't made of granite. They were made of water ice. At Pluto's extreme temperatures, around minus 378 degrees Fahrenheit, water ice behaves like rock, stronger than steel in some conditions. There were vast plains of frozen nitrogen, and even more astonishing, glaciers. Nitrogen glaciers slowly flowing across the landscape. Flowing. Movement means energy. Energy means heat. But how could Pluto generate heat so far from the sun? the answer was hidden beneath its surface. Data from New Horizons hinted at something extraordinary: a subsurface ocean. Liquid water beneath miles of ice. On a world colder than Antarctica, colder than Mars, colder than most known places in the solar system. On Earth, water freezes at 32 degrees Fahrenheit. Pluto's surface is nearly 400 degrees colder. So how could liquid water survive? To answer that, scientists had to rewind the clock 4.6 billion years. For years, researchers believed Pluto formed slowly in a cold start scenario. Small, icy objects gently collided and merged over millions of years. In that freezing environment, Pluto would have formed frozen from the beginning. However, surface evidence told a different story. When water freezes, it expands. You've seen it crack pipes in bottles in winter. So scientists examined Pluto's surface for clues. If Pluto started frozen and stayed frozen, we would see compression features. If it began hot with a liquid interior that later froze, we would see expansion features. The evidence showed expansion. Impact craters were stretched. The crust appeared pulled apart. Even the oldest terrain showed outward stress. That means Pluto once had a liquid interior, which means it formed hot, not cold. Modern simulations suggest Pluto may have formed incredibly quickly, possibly in as little as 30,000 years. Massive impacts between icy planetesimals generated intense heat. That heat melted the interior. A global ocean formed beneath the crust. Radioactive elements in Pluto's rocky core continue releasing heat even today. Tiny amounts. But trapped under thick ice, that heat may be enough to prevent the ocean from fully freezing, which raises a breathtaking possibility. If liquid water exists, if energy sources exist, then chemistry can happen. And wherever chemistry and water coexist, life becomes conceivable. Not confirmed, but conceivable. Pluto may be just one of many ocean worlds. Other dwarf planets, such as Haumea, orbit in the same distant region. If Pluto formed through a hot, rapid process, perhaps they did too. Perhaps the outer solar system is filled with hidden oceans beneath frozen crusts. For decades, scientists focused on Mars in the search for life. Then attention shifted to Europa and Enceladus. But Pluto suggests something radical. Maybe sunlight isn't required. Maybe internal heat is enough. Maybe life could exist in total darkness. After New Horizons, many astronomers began questioning the IAU definition. Should a planet be defined by orbital dominance or by internal complexity? Pluto has mountains, glaciers, atmosphere, moons, layered interior, possible ocean. It behaves like a planet in every geophysical sense. The debate continues, but perhaps the classification matters less than the discovery. Because Pluto forced us to confront something deeper, our assumptions. For centuries, humanity believed the outer solar system was static, cold, dead. But Pluto shattered that narrative. It showed that distance does not equal inactivity, that small does not equal simple, that frozen does not equal lifeless. It expanded our imagination. And science advances not only through data, but through imagination. If oceans can exist 3.6 billion miles from the Sun, what about planets orbiting other stars? Our galaxy contains hundreds of billions of stars. Most have planets. How many distant icy worlds hide subsurface oceans? How many are warmed not by sunlight, but by internal heat? How many are waiting for their own New Horizons mission? Pluto may be small, but its implications are enormous. New Horizons did not orbit Pluto. It performed a flyby, a brief encounter, and then it continued onward into deeper regions of the Kuiper Belt. Pluto is already behind it, but for humanity, Pluto is just beginning. Because sometimes the most distant worlds reveal the most profound truths. We thought Pluto was the edge. It wasn't. We thought it was simple. It wasn't. We thought it was dead. It isn't. And in proving us wrong, Pluto may have become more important than any planet ever expected to be.